Hello and welcome to Desktop Experts. Now this is a very exciting idea I've had. I don't know that I'll get any support from anywhere else, but this is the Australian power grid. Now numerous connections are available on the east side. Hydropower from Tasmania can get sent to Victoria in peak times. Off-peak power from Victoria gets sent to Tasmania in peak times. When South Australia is really windy, they send their power everywhere. We've got a lot of pump storage hydro in Queensland. And we sort of move electricity around this area as we see fit, or as the market demands. Now, this area out here, Mount Isa, that can be joined in, and there's a project at the moment called Copper String. They're going to join renewable energy out here. They're going to join it to the main Queensland grid and then subsequently into the national grid. Now there's another project here where South Australia will build a power line across here, so they'll be able to export their excess power into New South Wales and Victoria. So that'll be a third connection into South Australia for power exporting and off-peak power importing. Another project that exists is the Sun Cable project, which is a proposal to build lots of solar farms here and export that by an undersea cable 5,000 kilometres to Singapore. Now that is a project of an epic scale. Now here's another project called the Pilbara Energy Park, where they plan to build a massive solar and wind farm out here and have some kind of, whether it's ammonia or green hydrogen, and export that to Asia and power this northwest grid. Now this grid is probably the third biggest grid in Australia. There's a lot of very, very heavy industry up there. It's all linked together and they all share power with each other. So, my proposal: from Wollongong, which is around here, very close to a major load centre, pretty much in the middle of this grid here, in the middle of the national grid, which is important. 1,800 kilometres away is a little watery island called the South Island of New Zealand. So I can skip across to the South Island of New Zealand, and we can see that in this general area here we have a massive hydroelectricity scheme where water from one of these huge lakes here is just tunneled through and dropped into the ocean here at a place called Doubtful Sound. Now my proposed cable, 1,850 kilometres, would end in here somewhere. And the reason I do this, I propose this, is that in this area there are massive lakes, massive mountains, and the ocean. So it would be an absolutely perfect spot for what I call a pump and dump hydro scheme, where we pump water up from about 400 metres, we pump it up to well over 1,000 metres in the off-peak, and then when we need the power, we've got almost 1,000 metre drop, and we can drop that water down into the ocean. Okay, so here's the proposed route of our cable, 1,850-ish kilometres. Wollongong is a major electricity distribution centre. There used to be power stations there, and there's a lot of high voltage transmission lines that lead in, out and around Wollongong, very close to this major load centre of Sydney. But what's increasingly happening now is that cities are also becoming generation centres. The amount of rooftop solar that Australia has is enormous, and it can lead to a situation where too much is being produced and the authorities want to investigate some kind of way to curtail that power. Now, don't get a renewable energy and waste it with curtailment. Send it across to New Zealand, where it can either power their grid or it can be used for what I describe as pump and dump hydroelectric schemes. So in these mountains, the Southern Alps of New Zealand, we have a lot of massive lakes. And those lakes can have their water pumped up to the top of mountains and then dropped into the ocean. So not only are we getting that initial 500 metres of elevation for our hydraulic head, we're using the pumping capacity from all this additional electricity to send that water up the mountain, so we're actually dropping it from more like 1,000 or 1,500 metres, depending on the chosen location. Now, Australia is a very sunny and very windy place, and when the sun is out in Australia, it's not necessarily out in New Zealand. So, when it's windy in Australia, it's not necessarily windy in New Zealand, and vice versa. So we can tap into their future solar, their wind farms, their hydroelectricity. If they continue with coal and gas, we can continue to tap into that until that's hopefully retired. So the distance when compared to sun cable is only 1,800 kilometres. Now New Zealand has about 5 million people, and Australia probably has about 20 million people that are on this grid. So we're joining up quite a lot of consumers, and the ability to share power between these reasonable sized markets would create more than enough demand. So we've got excess power going this way and a lot of dispatchable renewable power going this way. So it'd be a win-win for New Zealand. New Zealand would be able to tap into our very low-cost renewables, and we would be able to borrow from them their very expensive peak on-demand power that they have through their hydroelectricity schemes. And because the sun comes out at different times here, you're also able to smooth out that solar generation peaks throughout the day. Okay, so here's probably one of the best untapped pump and dump hydro sites in the world. So we've got this massive lake here, Te Anau, or Te Anau, and over here we've got Doubtful Sound. We've got the rear arm of Doubtful Sound. Now these two waterways are only 19.8 kilometres apart, and you'll see in the middle there's this lake. And let's have a look at the polygon there. 110,000 square metres. Now, we can pump from the level of Lake Te Anau, which is 179 metres, up to this level here, which is 1,463 metres. And then we can dump that water all the way down to sea level. So without even building a dam, we've got natural lakes and the ocean at all 3 points. Now this tunnel from the lake here could be quite level, and it actually accesses this one via a shaft. So we have a pump station here. We go up to the lake, that's accessed via a shaft, and then we have some kind of hydroelectric station down here at sea level, and do that with less than 20 kilometres of tunnelling. And obviously this shaft can be quite a round shaft to provide extra storage capacity to that lake. So basically what you're doing every day when it's sunny in Australia, you're filling this lake, and then when the power's needed for surges, we send that power down the hill to the ocean, and we use existing lakes. It's such a perfect spot for pump and dump hydro. Now, here we have a second location. It's in between Wakatipu and Milford Sound. So, what we have up here is the ability to pump water from this elevation. Yeah. Ooh. So what we have is the ability to pump water from this lake pump it up this valley. Probably at some stage here we would start boring a tunnel that would go to Milford Sound. On the way, there is this lake. Now this lake could be modified to create a storage of around 1,350 metres perhaps. There's an outlet to that lake there, so that could be modified. Create a high level storage up there. Somewhere there. A bit of extra dam. And that is our top dam. So we pump up through the tunnel, and the good part about this is that this tunnel here can all be on the same level. And there could also be some kind of minor pumped hydro as we send water down into that valley. So we're basically getting two uses out of this water if we go here. So there's obviously another mountain there, so we could pump up from that level to that lake there, store the water there, use that as the first stage of the pumped hydro, let it go down to this level, or potentially even use this valley just as a siphon to get the water up to the next, which would be the major storage, which is up around 1,350 metres altitude, and then all we have to do is drop that water down 1,300 metres and 10 kilometres down into Milford Sound. Now the hydroelectric potential of this is absolutely enormous. With the ability to send excess power from Australia to the New Zealand grid, the ability of the New Zealand grid to use that power for storage at these two locations, and the ability for sunlight and wind in Australia and New Zealand to offset each other, I think this project's a win-win. Now, there is no example in the world yet of an undersea cable going that distance, but I believe it to be very possible. Sun Cable talked about going nearly 3 times that distance to go from Darwin to Singapore. So, just because no one's done it doesn't mean it can't be done. So, we've got the whole east coast of Australia grid being able to link to the New Zealand grid. So, it's a very interesting proposal. Lots of upsides for New Zealand. Very minimal in the way of environmental damage. Most of the infrastructure is underground in both of these locations. So it really could be a benefit to both countries. And that's the idea I've had, and that's thanks for watching Desktop Expert.